just going to make it display as a box and not renderable. And I'm going to use a brush source in order to create a thin layer of smoke on top of the solid ground, and this will help us get also more realistic effect on the simulation, and this way the explosions will interact with this smoke and they will draw it in as they rise up, and they will also create shock waves on it when at the moment of their explosion. So you will see the effect finally, and I think you will like it. So set the temperature to 300, which is in approximately in Kelvin. 300 degrees means neutral temperature. It's 0 Celsius, and the smoke will not rise, and it will not go down. And I will set the discharge to 100, because in brush mode this means percentage. So 100% means that we will just print the content of the simulator with 100% of this temperature and this smoke here. So I'm going to animate this in order to imprint it only for the first frame, and then set the discharge back to 0. Okay. So we can, once a control run of the simulation, we can see that this effect here, it happens because we have not excluded the brush box from interacting with the simulation. So okay, so right now it's better, but all of our explosions go off at the same time. So we're going to have to change their timing. So again, the more irregular the timing of the explosion is, of the explosions, the better. So I'll try to spread them out in more irregular fashion. Okay. I'll delay this one a bit. And okay, so let's see how this will do. So while the simulation carries on, I will show you the render settings that I prefer to use for this one. So first off, I'm going to set the smoke density to 0.9, and I'm using the simple smoke option because we don't need a more complicated transparency opacity diagram right here. The simple smoke will do. I just increased its opacity in order to get a more dense and more epic effect to the smoke. I will also change the smoke color to a bit more brownish, like this, and the effect of this will be a more red tint on the shading of the explosion. I will also use the analytic plus shadow scattering right here. And then I'm going to enable the emissive white and use the new grid-based self-shadowing that is introduced in the latest Phoenix 2.2. So the difference between it and the previous ray-traced self-shadowing is that the ray-traced self-shadowing produces naturally noise, and you need to wait a while for the noise to clear up. So the grid-based self-shadowing, it produces a result without any noise, and it works also a little bit faster than the ray traced shadowing, but it shades only the content of the simulator itself. So in order to white up the surroundings of the container here, you still need to automatically use the Phoenix option to place either max whites or V-Ray whites inside of the simulator. So you have three options here. You have the simple placing, which is a spherical placing just around the hottest or the brightest actually part of the simulator. You have the inside placing, which is a smart placing and calculates where it needs to put the whites, and the problem with it is that if you are animating, and you may get some flickering because the positions of the whites are changing with each frame. And in order to cope with this problem, the new Phoenix now has the reduced grid white placing option, which will place the whites in actually a grid with a lower resolution. So here is the grid reduction. It will use by default 10% of the original grid, and this way there is no flickering even with a more dense smoke, except in the cases where you're just